Yes.
correct دكتور.
Okay. يلا. Sorry, the recording as well. طيب شباب, we arrived at this stage at which this kind of multiplication creates a square matrix, right? This creates a square matrix. So if that matrix is squared, or a square matrix, then basically we can find its inverse, right? So I can say, خلينا مرة ثانية, if x transpose x times c equal to x transpose y, basically we can find the inverse of this kind of multiplication. And this gives us that c vector, which contains constants a and b, equals x transpose x, طبعا, to the power of -1, which means the inverse of that multiplied by x transpose y. Let us double check that quantity. This is 2 by n, and that is n by 2, and that was 2 by n, and that was n by 1. Okay, so etc. That cancels out and gives you 2 by 2. 2 by 2 can be multiplied by 2 by n, and that cancels out. So the end result is a 2 by 1. Okay, right, so what do we call this procedure, or this kind of inverse? We call it, that is known as a pseudo inverse, as a P letter, pseudo inverse. Okay, it's a pseudo inverse. It's not real. It's a fictitious inverse. The only reason for doing so is to find the coefficients of the linear fit. Now, since that is an important relation, let us put it in a square box. Okay? So guys, we found now the coefficients A and B. We found the coefficients. Let us retrieve right now for a minute. Why do we call it least square fit? First of all, because least, it minimizes, this approach minimizes the error, right? So it is the fit with the least error. Square comes of the fact that you are having or squaring this system, right? Which we did over here. When we took the error and
we squared the error. Yes, yeah.
We took the error and we squared it, exactly, right? So it is least error, it is a square, and it is a fit, okay? So that's why the name comes about, okay? All right, so now we found A and B. We found A and B, okay? We found A and B, and over here I'm just saying that the sum of the error squared is given by that notation. And by the way, it won't make any difference if the equation that you had, A minus AXI plus B, okay? It won't make any difference if you are solving for AX plus B, the function that you want to fit, or A plus BX. What is the difference between case 1 and case 2? Case 1, A is the slope, right? A is the slope, where B is the intersect with the Y. That is B. For the other case, A is the intersect with Y axis, and B is the slope. But at the end, it depends on which equation you want to fit. It's the same procedure. Over here, what do we have? Sigma. What does that represent?
Standard deviation.
The standard deviation. Deviation. Okay. Right, so what physically what does it represent? Suppose I have the following data point. Both of them have the same mean. X bar is exactly the same. But for this case, case A, in comparison to case B, the standard deviation, the spread of the values, sigma, is smaller in comparison to the spread of the values in case B. So the standard deviation kind of measures how the data are spread across the mean value. Okay, so a higher standard deviation means you have a high spread of data points, and the smaller standard deviation means that most of the points are clustered around the mean value. Right. I need just in order to finish the requirement to use the best fit is to define or to show you how to define a function in MATLAB. Okay, if this is a function a plus bx, how can we define that in MATLAB? So if the function that you want to define at x, which means this function f is a function of x given by a plus b times x. This is how we write it in MATLAB, okay? If the function had multiple variables, function of, let's say, x and y, then how would you write it? F at x comma y, then write the function that you have, and so on. Okay? And so on. All right. Okay, guys. So now let's consider the following example. We have the following data point: 0, 1, 2.2, 2.5, and 3. X and Y. 0, 1, 2, 2.5, and 3. Guys, can you go ahead and define X? Make it as a column vector. Define Y. Make it as a column vector. And plot X versus Y.
Yes, Doctor.
I will pause for 2 minutes, and I expect everyone to do this step.
شنو نسوي دكتور؟
ارسم الاكس والواي.
Okay, Doctor.
شباب, I hope that you are all done with this step.
دكتور,
Now,
is the standard deviation same meaning as second moment of inertia or second moment of area?
no, I'm not sure if that is correct. I don't think so.
Okay.
Okay. طيب, guys, let's define x and y. So x was x0, 1, 2, 2.5, 2.5, and 3. What is it correct?
Transpose, yes.
طيب, what was y, guys? أنا أخذها من الصفحة الثانية. It is 3.9, 3.7, 4.1, 4.4, and 5. Again, this is transpose type. This is x and that is y. I don't want to see the values on the screen. So use a semicolon, then a plot, x versus y, and we will end up with something like that. طيب. So, in fact, I want only the data point. I don't want to see the line in between. So how can we do that? We can use O to represent that the data points are given by this marker. طيب. And maybe I can give it a different color, a red color. So yeah, this seems better for me. Okay. We defined or we plotted the data points. What do I want to do? Now I want to define how many points. I will do this procedure now. I will do this procedure. I'll create this X capital matrix. Okay. I will create X capital matrix. I will take the transpose. I will multiply it by X. I will find the inverse. I will multiply it by X transpose times Y, and I will find the coefficients A and B. Okay. A and B. So first of all, let us decide the following. Do we want to see the function that we want to fit? Is it A plus BX or AX plus B? So for the time being, let me pick A plus BX, okay? Let us pick this format. Let's pick this format. Let's switch to MATLAB again. So guys, N is the number of points. So how can we define N?
Length of Y, length of
Length of X or Y. Basically, they have the same data point. So that is X. Like, what else? I need to define capital matrix, right? X capital, Shabab. Let me write it on the screen. This X capital matrix, remember the equation that I want to fit is A plus BX. So the coefficients that we have in vector C are A and B. And the X capital matrix, what do you see over here? The first column, what does it represent?
the coefficients of A, all one.
Which are 1, 1, 1, 1, 1, 1, correct? And for B, it is x1, x2, x3, all the way to xn, correct? So how can we write that in MATLAB now? How can we write that in MATLAB? So guys, can you see that the first column is ones? We can create it with the ones command in MATLAB. How many rows do we have?
N.
n. How many columns do we have for the 1?
1.
1. Okay. So guys, if you run that code, you will see that this is X capital, it has 1 column, 1, 1, 1. What about the second column? The second column, which should be attached over there. It has the value x1, x2, x3, x4. So basically, it is the small x. It is basically this x vector, x column. So if you run that command, that is the 1, 1, 1, 1, 1, and this is the x vector. Can you see that? And the size of x capital as 5 by 2, which is n by 2. Okay, n by 2. Now, let's see. X transpose, and you multiply it by x matrix, you will end up with a square matrix, and that's true. Take x transpose times x. Okay, and we said this is times c, and that is equal to x transpose times y, because we need to multiply both sides of the equation by the same matrix or coefficient or variable, correct?
Doctor, shouldn't x be with y? Shouldn't C be alone on one side?
شلون عليك؟
Shouldn't the C matrix should be alone? Then just x inverse. But the
No,
x,
I'm saying. Okay, I'm saying originally the problem was x times c equals to y, right? So then we multiplied both sides by x transpose, then x transpose. Originally we started from that, we multiplied both sides by x transpose. Then we need to take the inverse of that quantity, right? So let us cut that part, and we multiply it by inverse of x transpose times x. Okay? The inverse of x transpose times x transpose times y. Let's run that code. Here are the coefficients now. 2.9 and 0.6. So what does the first element represent?
the value of A.
The value of A. Okay. So basically we can say that A equals C1 and B equals C2. Basically we are extracting the values of A and B. Right. Let's define the function now. F is a function of x, and that function is given by A plus B times x, isn't it? خلينا أمحي لكم الجزء شباب من الشاشة. Okay. So we defined now, we found the coefficients A and B. That minimizes the error, okay? That minimizes the error. All right? What else? I want to plot the new linear relation that we have on the same graph. So what shall we do now? What shall we write over here?
Hold.
Hold all, okay? Hold all. Basically, any new curve it will be plotted on the same figure. So now plot what? X versus what?
Versus F.
Versus f of x, right? It's a function.
Yes.
This is a function. So plot that stuff. Okay, and this is about what we have. And you can see that our curve, which we created, is passing in a very nice way between the data points that we have. Is it clear? شباب هاي اللي كنت تسوونها في الفيزيكس 209 I would say. When you created the legend or created the curve or the equation that passes through the data point that you have in your experiments.
Yes, the word I mean the Excel automatically did it for us.
It automatically generates that for you. Now, basically, you know how you can code it yourself. Right. What else do I want to calculate? I want to calculate the error. So error 1 equals to
Equal y 1
minus f of x, I would say, right?
okay, the matrix okay.
Okay. So if we do so, guys, this is basically the error at the first point, the error at the second point, the third, the fourth, the fifth point, right? And each point, sometimes you can see that over here it's below the curve, so it's negative. Over here it's above the curve, positive, below, negative, positive. مثل ما طالع عندنا. Okay, so what shall we do in order to find the sum of the error square? S equals the summation of the error dot squared. Why do I put the dot operation?
Because it's element-wise squaring.
Element-wise operation. Each element in this vector should be squared by itself. And if you do it without that dot, we will see an error message. Look at that. Incorrect dimensions for raising a matrix, although E is a vector, but it is a matrix n by 1, right? So you cannot have n by 1 times n by 1. It's not defined. Right? Either n by 1 times 1 by n. But if you want to do it on each element, then you have to put the dot operation in order to square each element. Right. We did that now. We have the sum of the error squared. Okay. Now the standard deviation says sigma equals square root. That is the command for the square root. What was the square root? It was square root of s divided by n minus m. By the way, what is m? N, we know it.
It's the length. We already defined it.
M as the number of coefficients in the C vector. So how many coefficients do we have in the C vector in this problem for the linear fit?
2.
2. Okay, 2. Only A and B. So let's go over there to MATLAB again. I will say that M equals length of C, and that is 2 again. So it is square root of S divided by, right, Shabab? Some of you will do that mistake, N minus M. Is that correct or wrong?
It should be the absolute value.
مرة ثانية.
It should be the absolute value because you can't have negative numbers in the square root.
No. S is already square. It's positive quantity now.
Doctor, we have to put n minus n between brackets.
N minus M, exactly. شباب اللي كتبته في هالسطر غلط لأن عبارة عن square root of S divided by N minus M. هاي اللي كتبته. Just make sure you put the right parentheses over there. The equation was S divided by N minus M, not S over N minus M, okay? just make sure you write it in the right form. Okay, so we should write it as n minus m. So that is the standard deviation, and as the sum of the error and the standard deviation, as they are decreasing, okay, the smaller the error or the sum of the error and the smaller the sigma, the standard deviation, the better the curve that we have. Okay, the better the curve that we have. It means that the error is small and the curve that we came up with is representing the data with the least error. واضح شباب الشيء؟ All right. Do you have any question regarding what I described today? Okay, I don't see any question. Let me stop the recording right now.